Thank you for coming. So here we are our team from Google Cloud, and we have very senior architects here who are database specialists, Tushar and Rishi, and myself, Nakul. I am also part of the database practice team and supporting the technical GTM activities across APAC. So this session we have kind of kept it pretty open. Now we just wanted to understand, and we want to call it like ask me anything kind of a session. We just don't want to keep it specific to a topic, though. If we see and hear from you that there is a specific topic that we want to get into, then we can really get into. So for example, let's say if you really want to talk about the breadth of database services in Google Cloud, or we want to get into depth into a particular database service, since this conference is more about Postgres, so what all Postgres options do we have? Like maybe Cloud SQL as a managed Postgres offering, and then AlloyDB, which is Google's engineered version of Postgres. And then there are a lot of advantages there. It is faster, there is decoupled storage and compute, it is very fast for analytical queries. So so on and so forth. Spanner also has a PostgreSQL interface which lets you connect and run applications at scale. So and then if you do not want to talk about, let's say, just only Postgres, because I know people here are from databases background, and you really want to talk about anything from a database standpoint, as in like use cases, maybe any challenges that you guys might be facing, or what kind of patterns do you really see, and then how do we kind of help them solve with solutions at Google Cloud. And then if you really want to have discussions even outside databases, right, so we can even help do that, right? So we just don't want to focus on anything like just like one thing, because there are other sessions which are happening at other halls which are taking you in depth into a particular topic, right? So this session is more about hearing from you and having an interactive discussion. And then of course we have all the content and everything available. If there is one particular topic that you want us to delve into, then we really can go ahead with that, right? So how does that sound? Right? Okay, so I think, how do we want to take it, right? So maybe we can just start with questions rather than we giving you an input as to what
just to start and as a starter, right? So I hope you
so maybe Tushar, you want to take
So these are like 4 different flavors of managed offerings. Managed plus something which is like very open, the AlloyDB Omni part of it, which has essence or roots going back to Postgres, right? Now one might naturally face a question like which engines to choose when we have multiple offerings in place, right? So our answer is, it purely depends on what is your use case, what you are solving it for. Okay, whether you are just building a normal transaction processing OLTP application, or you want to have a flavor of mixed workload where you want to also do some sort of real time analytics, okay, because that is also something which is needed in industries like CPG, retail, e-commerce, fast commerce, right, where you want to know like how many orders did I process in the last 1 hour or in the last 4 hours, right? And every time you don't want to kind of really see the data moving from the system of origin, which is OLTP, into your data marts and data warehouse, because in few scenarios it will need some additional processing and time to become available, right? So that is the beauty of having analytical solution available in real time within the operational database itself, right? So that's the essence, like when you would kind of really look forward to using something as good as AlloyDB. And then there is something wherein you want to kind of have practically infinitely scalable application. You want to run it across the globe. For example, there are some gaming companies, right, where you have this multi-role play games where players from different geographies across the globe, maybe someone from Korea, Japan, China, India, and even from Europe and US, right, they want to kind of play the same game and participate in the same event, right, contest. And we have solution for that coming from Spanner, which is our globally distributed relational database, right, which will take care of ACID semantics, but at the same time give you the scale, which typically only the non-relational databases we have big table and there are so many others, right, which will provide that part, which is but eventually consistent. That's not something that we want when we have players in real time, and everything that happens needs to become visible to everyone across the globe, right? So we have different solutions in place, and we'll be more than happy to discuss with you if you have something ongoing and you are kind of in a dilemma, like what is the best solution that I should kind of start with. Not that they are not sort of intercompatible. Of course we can move from one to another, but it will become a migration journey. How if we know upfront like what's my use case going to be, how it is going to scale, what are the different feature functionalities that we are going to build over the period of time, right? So that only kind of gives us a good foundation to start thinking like what my overall stack should look like, right? Not just the database part, but even the front end, the middle tier and whatnot, right? So we just want to kind of keep it open there. If you have something on your mind like, okay, we are currently here, these are our set of challenges, can you please suggest what would be the best landing platform for it in Google? Not just database, but even we can extend it beyond that, right? How do we do analytics? Why analytics is important? I mean, we say that there is real-time analytics available in AlloyDB. Does it become a replacement for a full-fledged data warehousing solution like BigQuery that we have as a warhorse in analytical world, right? Everyone serves, or each component serves a different purpose, and they are complementary to each other. So it kind of forms a upstream, downstream kind of chain, right? Where the data flows from one system to the another, and there are different use cases that are served out of those. All right. So again, just reiterating, what is it that is specifically on your mind? Like how does that HTAP works, or how maybe like even extending it to, I think we already spoke about the vector embeddings and how AlloyDB and Postgres in general is kind of help building those use cases with database being the foundation layer for the operational data and also storing the embeddings, right? How do we make these databases participate in the RAG based application which will leverage the online data and the what you call vector embeddings that are generated using the online data as well. Sure.
So see, if you leave it to us, we can talk for.
Yeah, I mean, we can keep going, right? We have a lot to talk.
So let me ask you this: are you aware of all these databases that are there on the screen? Okay, which ones have you worked or maybe know of? Cloud SQL.
I have a question.
Yeah.
We have seen in the Cloud SQL and Cloud Spanner. So when the customer scenario or a use case that we look at, so on what metrics do you suggest the customer as to go about? Hey, take a look at the Cloud SQL versus AlloyDB versus the Spanner. So what are some of the very high level metrics that we would look at? Use cases of customers that we would look at?
Sure. So I can talk about it. So let's say so when the choice is something where the customer is only looking for a managed database, 100% open source database, but a managed database service on top of that, then customers can really choose Cloud SQL. Okay. Now, having said that, each flavor of the databases that we see here has so one advantage or certain trade-offs, one versus the other. So, and that is what your question is precisely, right? So,
I want to pick up
yeah.
brains and Tushar's is. So, when some customer who is already on Cloud SQL, right? Tushar did mention that.
Yeah.
Hey, if I need to migrate from the Cloud SQL to AlloyDB or for that matter,
Yeah.
Spanner, right?
Yeah.
There is a migration journey.
Correct.
How smooth would that be? Is also something you can throw something out.
Sure. So let's first answer the.
I hope the questions are audible, like what gentleman is asking.
Yeah. So let me just rephrase the question also. I think that will be better. So the question is that we are saying that from a Postgres standpoint, okay. So since this is, we have different services. But again, when we say Cloud SQL, we are saying enterprise ready, fully managed Postgres database. Then we are saying Alloy DB, which is again Postgres compatible, HTAP database. And then we are saying Spanner as well, which has a Postgres interface. So then what is the selection criteria from a user standpoint, like you folks, on when would you choose one versus the other, right, at a high level, right? So that is precisely the question. Best fit for the purpose, right? So while the answer is subjective to a very detailed discussion, and when we get into what matters to you the most, okay, so if performance is what is matters to you the most, and you are looking for again an open source compatible Postgres compatible version where you require both OLTP and OLAP capabilities, right? And that is why HTAP means highly transactional analytical processing database, right? So then we suggest Alloy DB. So let me just give maybe a two-liner description for each of those, so that then we can kind of dwell into each of this, right? And it's a very good question, because that is when you are working in your organizations and when you are working on your use cases, this is something which is bound to come, that okay, I know Postgres, which is fine, but then which amongst these do we choose as our choice of database, right? So Cloud SQL is a managed service on 100% open source Postgres database. And when we say managed, which means that you don't have to do any installations, the backups are taken care of, the upgrades are taken care of. Upgrades, of course, upgrades do not happen automatically, because we know that in databases, upgrades may require some kind of an application change. If it's like a major version upgrade, for minor version may not, but then there are chances of planned regression that happen and so many things. So upgrades, the choice of upgrade is yours, but then the flexibility of upgrade, as in like the automating part of upgrade is there. Then there is automatic restore, backups, and then all the observability factors, right? Which is like system insights, query insights. When I say query insights, what is taking time, what kind of wait events are taking time, and then you drill down into exact wait events, query plans, and everything, right? So all of that is taken as part of the offering, which is Cloud SQL. Well, I said it's like, I can say one is the superset of the other. So what I say for Cloud SQL, all of that is applicable to Alloy DB as well, right? But Cloud SQL is like it can be your entry level as a managed service into Google Cloud, right? If you want to really compare, because we are talking about the industry here, so you can compare it with the RDS of the world of, let's say, what AWS has, right? Or a managed SQL offering, or Azure SQL that Azure has, right? So that is what is Cloud SQL is. Anything else that we need to add?
Yeah, I'll just add something over here. So standard application, standard performance I need.
Yeah.
Start with Cloud SQL, right? I need little better performance than this, right? I need little more cache. There is something called Cloud SQL Enterprise Plus also. So you need more caches. My business is growing. I need more read performance. Enterprise Plus. Now, now my requirement changes a little more. I need more performance on top of it, right? Although those Cloud SQL features are something very important for me, but I need more performance. My use case has extended to OLAP also, where I want to do some real-time analytics also, right? Choose Alloy DB in that case, right? And migration journey, by the way, is smooth. You could use migration tools, and then there are technologies, and then there are commands through which you could migrate, right? Now, Alloy DB will not only give you a high performance on OLTP, but also adds a columnar engine to your Postgres, so that you can do your OLAP queries, summarized queries on top of it. And the beauty is that you could keep your primary for your OLTP workloads, and you could have replicas for your OLAP workloads. So you can have a mix of both, as and when you expand your business, right? Now, what this also, gives you is, much lower latency in terms of replicas also, right? You can keep adding replicas, as and when you can, and you can have thousands of replicas. Now, with that, now my business even grows further, right? And now I want even more scalability. I don't even want, write once, read many times, which was what AlloyDB was serving to me. But now my concurrency is also increasing, right? Now I want horizontally shardable database, but I have an application which is Postgres compatible. What do I do now? What I can do is I can move towards something called Spanner. Spanner will give me horizontally shardable database. You wouldn't have even heard, RDBMS, which basically scales by adding nodes itself into it, right? So usually in RDBMS you would have heard, if I want to scale, I can scale vertically, which is I keep on adding some more vCPUs to it, right? Or maybe adding some more memory. But when you add node, actually, the performance is linear in terms of concurrency, in terms of performance, right? And that is where Spanner actually, works like a charm, right? So that's where, Spanner is. Now, I also have I'm under some regulated industries, right? And these regulated industries don't allow me to put it on cloud right now, but I want to be cloud ready, right? And I want to have better performance along with, like, again, OLAP engine. That is where Omni comes into the picture, where Omni helps you keeping your databases on-prem, self-managed databases, but gives you a better performance in terms of, OLTP, and not only OLTP, but also gives you columnar engine, which you could have your summarized queries working much faster as compared to your normal indexes as such. So that's pretty much in the nutshell. And maybe if you want to add more,
just adding a little bit more on Spanner. So how many of you have heard of the CAP theorem? Yeah, consistency, availability, partition tolerance, right? So what does it say? So is that at best you can have 2 of the 3, right? And that is what gave birth to the NoSQL databases, right? Relational databases have been there for about 30-40 years, right? And then I think maybe early 2010s and everything started seeing the evolution of NoSQL databases, which is not only SQL databases, which are more like purpose built databases. Some databases are more optimized towards documents, some are key value stores, white column stores, graphs, right? So there is a whole lot of variety of NoSQL databases, right? Now there was an emergence of another kind of databases, which is new SQL, right? Now people do not want, if you really see from a user perspective, right? So from a user perspective, and take a user's journey and the kind of applications that you might be building, right? So a typical application where, let's say, we can take any example, let's say take a retail application example. So for a retail application, you would require, let's say, a relational database for payment processing, where consistency is the key, right? Then you would also require a key value store for building a cart app functionality. Then if you want to build a recommendation systems, then what kind of data structures are best for building recommendation systems? Graph databases, because there is an entity, there is a relationship. Then you might also want to build a search system, right, which is like a text based search system. If I'm looking for, like, let's say catalog search, t-shirts in green color of L size, right? So then it kind of give you all of that. So if you really see now, with NoSQL, it's like a purpose-built databases. But if you go to really now start building an application which has so many different facets, then you would require at least 7-8 different databases, and many of organizations right now are using that, right? And then you kind of build a microservices layer on top of that, which kind of connects to each of these databases in isolation. And then there's another whole world problem of integrating microservices and communication between microservices and security and so on and so forth. So what Spanner helps you, and why I started from CAP theorem is where I will come back to, is that the new age of database, which is Spanner, is a new SQL database, which is multimodal in nature, which means that you can build a lot of these use cases, different kind of use cases, where you do not need so many different categories of databases. So with Spanner, which is at the heart of it is a scalable, horizontally scalable relational database, which itself means that it is kind of able to satisfy all 3 quadrants of a CAP theorem. it has now added functionality for graph, which means it's a managed graph database. You can do full text search. You can use it for key value pair storage. So I think and as a vector store as well, which means that you can generate embeddings, store embeddings, and create vector indexes on top of that, so that you can build Gen AI applications, right? So as I said, right, so in the beginning, that it is like, one is the superset of the other, right? So as Rishi pointed out, is with Cloud SQL kind of view is like an entry level where you're looking for an average functionality, only relational, and a managed service. Then you kind of get into Cloud SQL. If you are looking for higher performance, something which is industry innovating kind of a functionality, where you have HTAP functionalities because of columnar engine, then you kind of switch to AlloyDB. By the way, AlloyDB also has very nice integration for supporting generative AI applications, because it helps you store embeddings and create vector indexes. Now, when we're talking about vector indexes, there are different kinds of indexes, right? So all that is available in the open source Postgres PG vector extension, which is like the HSNMW, IVF flat. These indexes are there. But then with AlloyDB, you also get support for SCAN, which is Scalable Approximate Nearest Neighbor, which is Google's own vector index, which has been developed by tens of years of research. All our Google products use SCAN in the background, not only now when you're seeing generative AI, but it has been powering maps, search, and YouTube. All of these three applications are powered by SCAN, and that is now available, where you can kind of use SCAN for creating indexes over embeddings, and then use it back into your application, right? So that is again with the AlloyDB, but AlloyDB is again not truly multimodal. Spanner is multimodal, where you can have, as I said, graph, full text search, relational, as well as vector kind of stores, right? So depending upon the use case, you have like one versus the other, right? I know it's a very long answer to your question, but yeah.
And just on that multi-model thing, right? It's a true multi-model, by the way. So it does not mean that when you go to Spanner, you launch only a graph database and only graph will work, right? Your graph queries work on the same RDBMS tables itself. Your full text search works on the same same RDBMS tables itself. You don't have to launch a separate one, and only that use case will work. The entire RDBMS to full text to the entire graph queries will work on same RDBMS table. So the idea is that you don't change your schema as such, right? The idea is the schema behind the scenes remains the same. You don't need to do any specific ETLs on top of it. You leverage the same schema functionality data, but for other use cases as well, which you have not been able to do that, or maybe there was a expensive ETL process doing that, right?
And so GraphQL being combined with SQL helps you to use the same SQL for querying both graph as well as the regular SQL. So that is how the joins are seamless.
So basically there is no movement of data. Data just resides in one place. We call it colossus in Google terms. So that is what our persistent data store is for all our bigger application databases, right? That we use Bigtable or Spanner or whatever, even in AlloyDB, right? So essentially we are saying that while it is polyglot persistence at higher level, right? We are not actually moving the data. The data is the same. The same table data is going to be accessed by the graph, which is having its own representation in form of nodes and vertices, right? But that relationship is all kind of based on a wrapper or a layer that is built on top of the relational data that is stored in those tables, right? So that's the beauty of it. Without moving data, we are able to kind of power an application which will have this multifaceted functionalities, right? Which Nakul very beautifully spoke about using e-commerce application like a Flipkart or Amazon, right? These functionalities are actually required in real time, as in like we want to do a transaction, we want to search a catalog, they want to show us online recommendations. So these are all real requirements, and they can be actually served through these engines. So yeah, the question again, like how we explained, right? sometimes we have a very good detailed understanding like how my application is going to evolve over the period of time, right? We know the MVP, like where it is going to start as a minimum viable product, and then it has its own uh, future journey, right? As in like enhancement coming in. If we have a good idea of it, we can start with the end state engine itself, and that kind of helps us to kind of evolve in a simplistic way. But many times it doesn't happen, right? So in that case, we just start with something which is like entry level, the most simplistic version of our operational store, and then we can actually graduate it to the next levels based on how our application is kind of taking its new forms, what we want to do with it, and so on. Hope that helps you to kind of get a good idea like when to use what based on what use cases we are working on. Please feel free to ask us like if there is anything on your mind, like how do we do, let's say, hybrid, or how do we do even the migration from your on-premise if you are running something like an on-premise inventory or estate and want to adopt cloud, the managed services part of it, or even if you want to kind of do some sort of multi-cloud offering, right? Let's say someone is being used as a primary, the other cloud is standing there as a, let's say, active site or a DR site, right? Anything that you have on your mind, please feel free to ask us. Anything you want to add?
Hi. I have a use case which I just wanted to know, like which database and what architecture will be best for it. So there is one scenario I would take. First one is like we are having we are going to take Germany as an example, where we are going to have a read write node. So read write, and it's like the one particular instance where which is very critical for us. There is another instance which is a read heavy, but that is in a Singapore. So altogether both are two different regions, but both we need to have a same database. For this use case, which is the better option? And second scenario, both are going to be read write. Germany instance also is going to be read write. Singapore also going to be a read write. Same database, same storage. For these two use cases, which are the better candidates? Is it possible, or do we need to have separate databases? That's my question.
Excellent question. Yeah. So, for your first use case where you've got your read write in Germany and the only read only is in Singapore, right? I could very clearly see two databases. In fact, all of these databases would work, but to start with, Cloud SQL or AlloyDB, both will work in this case, right? Depending upon how much is your read workload, and also depending upon whether you want to do some summarized OLAP kind of queries also, right? So if you want to do that also, AlloyDB would work like a charm over there. The reason is that AlloyDB is specifically built for those use cases where you've got write once and read many times use cases. You can add as many replicas, not only in Singapore but also at many other places across regions. You could add replicas within the same region anyways you can, but outside of the regions also you can, right? With that also, if some of your workloads require summarized and the other ones don't want, in some regions you could have columnar engine, in some regions you might not want to have columnar engine also, so that will serve for you. Cloud SQL also gives you replicas, but yes, it will not give you that columnar engine as such, right? So both of them are completely Postgres, by the way. AlloyDB is also completely Postgres, in the sense that you can bring a dump of Postgres, restore it on AlloyDB, and also take a dump of AlloyDB and restore it back to an open source Postgres. So we don't stop you to do that, right? That's the first use case. The second one, where you want write in both the regions, right? That is where Spanner comes into the picture, and Spanner shines like anything on this, because that's again not only horizontally shardable database but also multi-regional as well. So you can opt for a multi-regional configuration on Spanner, where you have a write enabled in both the regions as well, and also you could have witness replicas, and then you could have read only replicas also if you want to with Spanner, and serve other regions as well over there. So both of these databases would shine, and depending upon how much is the data, depending upon the kind of concurrency that you're looking forward to, we could also opt for any of these databases over there.
So if you are building fresh and there is no legacy to it, as in like you're not migrating from, let's say, an existing incumbent Postgres heavy kind of architecture, then definitely AlloyDB would be kind of, I mean, if you are doing so, AlloyDB might be a good choice to begin with, because then you don't have to make lots of changes. But if you are building fresh and you have this aspiration of going global, then I think Spanner would be a good landing spot for you, because Spanner has certain requirements in terms of data model, like how the tables should be kind of related. For example, they should be having a primary key and so on. So that's the only thing that one has to do to achieve this real sharding based horizontally distributed architecture, right? So our suggestion is, if you are building fresh, it's like on the drawing board you are, then I think you can go with Spanner, because that will give you that will actually give you that scale insurance at whatever level you want. So today you are starting, let's say, with 1000 TPS as a concurrency, and tomorrow it might become 10,000 or maybe even 100,000. It's linearly scalable, right? So you don't have to really then rediscover the wheel that, okay, I mean, I have hit the roof now, how do I now scale? That question will not arise if you start with Spanner, if you are building an application which can have, I mean, like a very highly growing concurrency or even the data size, because Spanner does not restrict you on how do you kind of go global, be it in terms of concurrency or even in size of the data itself, right? So that's what we think should be your go-to option.
So for example, Spanner, you can create instances where it spans all three continents: America, Europe, and Asia. So in Asia, you will have Singapore, let's say, likewise you will have. So you can have like a, that kind of multi-regional, true multi-regional.
Thanks, actually it helps.
Just one more point I'll add. Not only that, you could start with PostgreSQL interface itself, so that your application is still compatible with Postgres code, right?
So this is in Spanner.
That's in Spanner, right? So, which means that tomorrow, if I, let's say, want to move out also, I don't need to make any changes on my application. So that's, yeah. Please go ahead.
I just have a follow-up question. So, let's take Cloud SQL as an example, right? If we have a writer and reader node, so there is going to be some replication lag for the reader to catch up. So the reads will not see the real-time data. But you are saying that Cloud Spanner is able to handle write workloads from two different regions without replication lag. Is that right? Is there no replication lag? Or is it still minimal or not?
Yeah, so see, there are two things. One is your multi-regional spanner. Multi-regional spanner will allow you to read the latest data, okay, which is, the latest committed data, right? In that case, if you want to read older version, you can. We allow you to read an older version also, right? And that too across multi-region. In a read replica, you could read an older version itself. So depending upon if you are configuring it on a multi-regional, you read it is not eventually consistent, by the way. It is strongly consistent. In a CAPS theorem, it is eventually consistent. But Spanner is not eventually consistent. It is strongly consistent, which means you read the latest committed data from your other regions as well.
So it uses the
Just
concept
to add,
of
yeah.
two times. The concept which kind of manages it. But if you really think that, okay, this microsecond and that microsecond it will be available, no. So these laws of physics have to, we cannot defy it, but the relative consistency and recency of that data, there is a two-time algorithm which is followed, which kind of manages that. So from an application, to be honest, from an application perceivability standpoint, it's like negligible.
Okay, so I mean, just to add more details for anyone who is interested. See, Spanner runs on a very specialized hardware that Google has to offer. So we do not rely on NTP protocol, which is typically used in cluster-based solutions. So we have our own atomic clocks-based syncing, okay, which is part of the Spanner machines, okay, and that is what we were referring to as the true time construct, right? The other part is we have this external consistency in terms of transaction consistency, right? So external consistency is the highest level of what we call transaction isolation that is offered, right? because every transaction that is happened will be seen as a serialized transaction, one after the other. Okay, so there is no confusion like which one originated first and which one next. What Rishi was telling is the tunable consistency part of it, because see, even if it is multi-region, writes are going to happen at a site which is designated as a leader site. Okay, so leader site is going to take the writes, it is going to distribute the writes to the other regions where I have my footprint present, right? But it will ensure that if you say that I want to have my read which is consistent, then yes, you get that. But if you say that I am okay with a stillness of, let's say, 5 seconds, then your performance or the throughput kind of greatly increases with that. And the good part is all these nodes across different regions for Spanner, they are connected on Google's backbone infrastructure, which has a very high bandwidth, right? So we don't rely on external ISPs and connectivity providers. So that is the guarantee and assurance that we offer in terms of consistency that will come through it, right? So when it comes to read, it is going to be that way. And the good part is, let's say if my default leader based region, if it goes down for whatever reason, the other one with the Paxos algorithm, the new leader will be kind of designated automatically, and the transactions kind of fail over to that. So lot of things which typically become part of our DR drill or DR construct, they are baked into it. Okay, so you don't have to worry like how do I ensure if the other side is going to see the committed data or not, right? So this is something which is by default given. But then there are some scenarios wherein I say, okay, I'm okay to kind of send certain module which is read only and has a threshold of like 5 seconds it can tolerate in terms of delay. I can say that okay, I'll kind of allow that, and that increases my throughput. Otherwise I have mechanism to ensure that what data I am seeing is the latest copy of the data or not, because the atomic clock based this thing is right, timestamping, it goes up to microseconds and nanoseconds, so that is attached to the transaction that happens. So we have ways and means of figuring out when the transaction actually occurred and am I seeing the latest version of the data or not, right? So that is the mechanism that is available, and hence we say this is actually how we have kind of hacked the cap theorem in a way, using our infrastructure, using this atomic clocks, basically the specialized infrastructure that we are using for Spanner. I hope like a long answer, but just helps you to put things in perspective, like how we are ensuring that it is a distributed database which is available across regions, and you don't really have to plan like okay, how will my DR kick in, because we say if it is a multi-region deployment of Spanner, you get 5 nines of SLAs, 0 maintenance, and you don't have to worry about availability and scale in that case. Yeah. Any further questions? Yeah. Okay, so depends there are certain standard topologies that are already available, like where you can place the nodes, right? Now if you say that I want to build a region which is across 2 things, one will be a designated leader, the another would be let's say, okay, now there are certain countries, especially Germany, Canada, yeah, no, because they have data residency laws, as in like including India, we have come up with the concept of dual region, multi-region, wherein we have 2 regions within that country so that my data doesn't go out, and at the same time I am still able to have a quorum which can take a call on whether I need to switch, or I have to kind of take a call that once site is down, I need to make the other site as primary.
Quorum in the sense, I'm talking about that if I have in some Asia for Mumbai, and from Mumbai I want it to be in Hyderabad as well, at the same time I want that permission. Bit of delay is okay for me.
Okay.
So is it something each Spanner have that the quorum of 2 should be there?
Quorum will be defined that way, so there will be witness replicas, and then there will be read-only replicas, and there are writable replicas, right? So in 2 regions, what will happen is we will have to have more versions or copies of data to take a call on that. But yes, that kind of works. And for the stillness part, you can actually mention within your query itself that I am okay to have that stillness, and it will ensure that it doesn't kind of really go and validate suddenly. So what happens, there is inbuilt mechanism in Spanner to make sure whether what data I am reading is a fresh data copy or is it a stale data copy, right? If you say that I am okay to have stale, it will not probably go and look up that thing that okay, what copy of data I am looking at. Alright?
And guys, if you, want to understand more in depth, we are available in the booth as well, right? So come to us in the booth, and we can, go in details with documentation along with you to explain you, what are the different regions that are available, where you can host, what kind of configurations are available. We are there. Yeah, I think there was a question over there in the last year. Please.
Okay. Now, as you mentioned, AlloyDB is more faster. Yeah, AlloyDB is more faster and better than Cloud SQL. So can you help us to understand what is the break even when we need to actually migrate to AlloyDB? That is first question. Follow-up question is like how expensive or what is the cost comparison between them?
Sure. So as I said, standard application, standard performance, whatever I'm, the commodity hardware that I've got on-prem, similar kind of a performance if I'm expecting. Cloud SQL, little notch in performance, Enterprise Plus, right? Then even better performance optimized machines, and then with AlloyDB we've also done kernel level enhancements with Postgres, right? Though keeping the compatibility same, right? But there are kernel level enhancements, there are storage level enhancements. So AlloyDB basically works on a no block write architecture, right? So it's a log only architecture. It hardens the block automatically underneath, without you knowing for it, and it gives you those, extra cushion for your extra transactions within, your nodes itself. So you can generate more, concurrency and more workloads right directly from the same number of nodes as compared to, I would say Cloud SQL or stock Postgres, right? That is where, so if I am throttling on, kind of a specific performance on Cloud SQL, I want more concurrency, along with I want more, shardable read architecture. That is where I will go towards AlloyDB, and I would look at AlloyDB. So, these days in gaming words also, right? You write once, but you kind of look at your dashboard many times, right? Okay. That is where, if there is AlloyDB, which is on a lower latency of read architecture, will help you much better than on a standard Postgres or a Cloud SQL, I would say. That's where you should ideally look for. But use case to use case, it could be kind of very different. Anything you would like to add, Tushar?
So, if particularly you are seeing some challenges, right, in your existing infrastructure, let's say if you are running the Cloud SQL Enterprise, which is the entry level offering, right? If you are throttling there, I think your immediate successor would be switching to Enterprise Plus, because that is literally one button click and you kind of upgrade to Enterprise Plus. Yeah, right. So essentially you kind of move to the higher tier of infrastructure that is running underlying and powering your database, right? So that would be your first step, because that's the easiest thing that you can do, right? After you are there and settled, if you see that there are still some challenges, or maybe your use case itself evolves, right? So far you are just doing OLTP, which I think will run fantastically well on Enterprise Plus as well, because it also has this concept called as data cache, right? Which is extension of your DRAM based shared pools, right? Shared buffers. So that is ideally going to kind of help you. But then let's say if your workload, use case or your workload is kind of becoming really bigger, you want to do HTAP, for example, right? And if you want to run multiple replicas, I think the economy of scale kind of kicks in over there. As you might have realized, AlloyDB uses shared storage architecture, as in the replicas, the more you create in the same region, in the same cluster, it will kind of use the same storage that is being used by the primary instance. Okay, so basically the more replicas you have, you will not be kind of replicating the underlying storage by as many times like how you would be doing in a stock Postgres, which is essentially that we use in our Cloud SQL Postgres, or Enterprise and Enterprise Plus both included. So I think a short answer to your scenario is, if you are on Enterprise today, move to Enterprise Plus, see if it is helping you, because see, I mean, moving things between two things is still a journey, right? Even if it is like facilitated using our native tools like DMS and would be a simple thing, we want to give it a shot, like if our use case is kind of getting what you call cater to using whatever engine it is. But this is how likely I would see it. If only my use case is evolving and or I seeing throttling at the highest level, I'll go to the next tier. Okay, so yeah, I think you had asked about it. What we have seen practically, Cloud SQL Enterprise Plus with data cache enabled. So data cache is like a optional component in Enterprise Plus. You might decide either way, but if it is enabled, the cost of it and the cost of AlloyDB, right? It is more or less in the same ballpark. But yes, as I said, if the number of replicas is going to increase, and that too if you are having a sizable database size, right? For example, 2 TBs, 4 TBs, or even higher, at some point in time AlloyDB will make more sense to you, because there will be some cost saving coming out of that compute layer.
Cost is kind of relative depending upon the use case as well, right? So, for example, in AlloyDB, the storage is cost a little lower, the CPU cost might be a little higher. The Cloud SQL would have CPU cost a little lower, the storage cost a little higher. So, use case.
It's a very nuanced thing. I mean, use case to use case, number of replicas you have, the size or shape of the instance itself, right? That is going to dictate like how it is going to be. But largely consider that they are going to be in the same ballpark for any vanilla kind of setup. Okay.
And if you are comparing it with let's say a managed engineered version of Postgres in other clouds like Aurora, then it will be much beneficial, because then in that case we don't charge you for IOs that they guys do. So okay.
Yeah. So.
Thank you so much.
But this is for the larger audience, right? Yeah, please.
So I have a question regarding the infra perspective. Let's say either in CloudSQL or AlloyDB or anywhere, if I am using let's say 10 CPU, is there a dynamic scaling is available? Let's say CPU crossed 80%. Is it in dynamic scaling will happen? Is there any provision for anywhere?
So Spanner does support auto scaling. Okay, it is CPU consumption based. So we set up thresholds like, okay, if my CPU consumption goes beyond 70%, then I can kick in the auto scaling part of it, because any kind of maintenance that happens in Spanner is doesn't kind of interrupt you. Okay, so it is that way. But yes, if it is let's say Cloud SQL or AlloyDB, and especially if you have to do the scale up in your primary instance, the vertical scale up, that will incur downtime, which is like going to be pretty small. But if it is again for the replicas part, then it becomes non-disruptive in that sense.
All about the technology. Relational databases always have had that challenge, right? And that is why the horizontal scaling came. That is why Spanner addresses that, because it is categorized as a new SQL rather than a only relational only database.
So while Spanner is completely auto scalable, Cloud SQL Enterprise Plus gives you scaling at 1 second interval itself, right? So you should remember that if I can afford for a second of a downtime for scaling up, you can opt for Cloud SQL Enterprise Plus also. It doesn't offer you auto scaling, but you can scale it up and scale it down at your wish. So for example, IPL is going on, right? So there are many applications that get launched during this particular point of time, and they only want it for certain time of the day, right? And they know that this is the time that I want to do it. Just before that, they scale it up. It runs for the entire match, scale it down. That's it.
So in enterprise, CloudSQL enterprise level, we without downtime, or downtime is there?
Downtime. So enterprise has a downtime, a little extra downtime. Enterprise Plus has 1 second downtime for scale up, for vCPUs and memory. Spanner, as we already said, Spanner is auto scalable. So there's no downtime.
Yeah, our case is basically what is happening. We are using CloudSQL. If it is 100% bottleneck is there, someone has to go there and stop it, or it's taking 1 or 2 5 seconds. So fine, we can wait. So you're saying
So what I would suggest is during that particular point of time, if you can scale or upgrade the enterprise to enterprise plus for that time,
Okay.
right? And enterprise to enterprise plus is also a 1 second kind of a just click of a button, right? Do that and then scale up your enterprise plus itself, and later scale it down, and then also you can downgrade from enterprise plus to enterprise also. Just click of a button. So you can do that also.
It will work. Basically, it won't
Yeah.
happen regularly. So let's say we are running cyber events, 3
Absolutely.
days events. Sometimes everyone has to watch every day what is happening. The CPU spikes. If 90% is there, we need to go DevOps. Please increase the height.
And for many customers, honestly, this has worked very, very well. This has worked because the downtime is, kind of, I mean, it is there, but yes, it is not known to the users in many cases, because many modern applications or every modern application has a retry logic anyways, right? There is a back off mechanism. So you don't feel that downtime anyways when it is kind of upgraded over there.
But I'll try enterprise version.
Sure.
I'll check on.
No, I think, yeah.
Hello everyone.
Yeah.
So my use case is like more of an extended to him also. So we have a variable kind of workload as a whole. So what can be the right fit? See, right now we are using the serverless option with Amazon. So what seems to be the right fit in terms of costing and automatic scaling, and like as we have auto pause and all the stuff with serverless. So what seems to be the right fit in terms of auto scaling and like a variable kind of workload setup, if we have, right?
So how spiky your traffic is, I think that will define the course.
It's like more of a payroll kind of systems, like where we have transaction running on into the second half or third week onwards. So like such is the kind of load. Like we have in 8 to 10 days there is a heavy spikes onto that, and remaining time it's just a landing zone, a completely silent zone out of it.
Okay, so I think, I mean, in my view, you might want to contemplate the option of spanner. Okay, I mean, assuming that you don't have like business logic running in the database, everything is running in app tier, right? Database is purely a persistent tier. I think spanner would do you the best justice, because it can start as granular as 1/10 of a node. Okay, and then once you kind of graduate to like one node, you talk in multiples of one node, 10 nodes, 100 nodes, depending on how your workload is, right? So that is one thing. One thing, I mean, because you mentioned that you are using serverless from another CSP, a common observation is that it is in the range of like 65 to 67% costlier as compared to a provisioned capacity instance.
Correct.
Okay, because see, someone has to bear a cost somewhere, right? As in like serverless, they don't kind of show you upfront, but they will have to kind of reserve the capacity internally or in the backend, right? So that's how serverless becomes costlier. But because your workload nature kind of dictates you to kind of run it that way, I think Enterprise Plus, because of whatever goodness it has to offer, like Rishi mentioned, right? The scale up, scale down operations are really fast over there. Okay, in the backend, like it's a matter of like seconds or couple of seconds, not more, right? Before a new VM kind of takes over. So that's a good idea that you can kind of contemplate. There are another options, like many people are running a sharded option on this as well, right? Maybe like sending some traffic to one instance, then another set of traffic or customers to another instance. So you can do it in a like a round robin kind of fashion. So that's also one thing. So while serverless as a notion or as a option is not directly available, we have ways and means which will be not as equally costly as the serverless option, but kind of gives you the same option. And see, I mean, because you are doing payroll, we know like what day of the month you are going to kind of see that thing, right? So if we kind of really time it well, I think we can actually win it even without going serverless. That's my
Right, we can switch it on.
Unpredictable workload, you don't have a chance for manual intervention. Spanner.
It automatically scales and just comes down.
And again, flipping it on, and I always give that cost angle as well. Serverless is never truly serverless in any cloud platform, right? What they generally do is that there are these warm-up instances which are already there.
Correct.
And then you always have to pay a premium. See, every time for a serverless offering, you always have to pay premium unless and until your workload is like very spiky during the days, right? So that is when truly for your kind of applications where predictability is there for the kind of spike that you are actually going to get, right? Which is like a payroll application. Something like what Rishi mentioned is something which will really be beneficial both from a performance as well as cost standpoint, because with a blip of a second, right, just like a refresh of an application, you kind of get a better or a lower instance as you wish. And then from a performance standpoint, because that is dedicated and not truly like a shared serverless kind of infrastructure, because what they do is that they will have kind of a provisioned instance, but the provision, because you're not using it, then somebody else might be using it, right? So it is not kind of shared, it's not kind of dedicated for you, right? So that both from a price performance standpoint, then this kind of a setup is much better for you.
Thank you. I think cost is still the major challenge with us, as you said. So we are still struggling with that serverless, but cost is the major side of it.
Yeah, that is why. See, so serverless is again, it's like it looks like a new kid on the block, and technology wise, okay, we are using serverless, but it is always that you got to pay the premium, because there is some warm up instances which is actually, because again, see, relational databases, all of this is a retrofit on top of the technology that has been existing for 40 years, right? So that is why you have all of this kind of a workaround, kind of a retrofit technology which is there on top of that. So it is better to utilize its strength rather than kind of using otherwise.
In fact, it's debatable to the point, because in my real world experience, even for like gaming customers where spike can come at beginning of a game or during a contest, even they are still going for provision capacity, because serverless has its own nuances if it has to scale beyond a point. That is where actually, you will start seeing delays, you will start seeing kind of error outs and timeouts, because the backend scale up mechanism might not be tuned to the traffic pattern that you see, right? So we still see very large customers who are using provision capacity have figured out their own ways and means of pre-warming their setup, right? So I think for all serious use cases, larger enterprises, I think provision capacity remains. We have to figure out our own sweet spot for that.
Yeah, but a good question.
Yeah. Thank you for that.
Sure.
Can you talk about the capability of the part of the database itself, or one needs to have two different schema for the OLAP and OLTP workload, or how is it handled, and how is the optimizer working? Is it a single optimizer that handles both kind of workload? How is it?
Yeah, I can take that. So see, essentially optimizer will see, and it is aware, because there are some flags that are specific to the columnar engine capabilities, right? So optimizer knows that I have two views. Now depending what kind of query I am getting, right? So there could be a table EMP, right? Which will, let's say, have a OLTP kind of query. Let's say, for example, I am just doing a point update or insert, and there could be a analytical query which is saying, give me an average of salaries of all the employees which are present in EMP table, right? So essentially EMP table will have two versions of it. One which is like let's say optimized for OLTP operation or transaction, and one which is optimized for the OLAP version of it, or the vectorized version of it, right?
So are you talking about two different materialized view of the same?
No, not so. Actually what happens is that within the memory, the columnar engine will have one version of EMP. So essentially there exists, at storage level there is just one EMP table, okay, which is, let's say, OLTP at its core. But because EMP table now has been identified as part of let's say columnar engine as well, there will be a version of it which remains refreshed. So transactions are still going to happen in the OLTP table. Whatever changes happen to it, they also need to get reflected in its EMP based the vectorized SIMD vector powered version of it, right? So that's how it is, but it is internally managed by the engine itself, the DB kernel. And as I said, depending on the nature of whether I want to do average of salary on EMP or I just want to do a point update, it will kind of take a view of that particular version of the table.
And
So-
the
so-
storage
so-
is same. It does not multiply.
No.
So if the question is, do I need to change anything on my application to access different query patterns? The answer is no. You don't need to change anything. Consider a table. I've got a table, and I know, I'm going to,
Maybe you can.
I'm going to do a lot of OLTP transactions. And I also know that this is going to be, very heavily accessed using some dashboard summarized queries and all, right? I can ask AlloyDB that, hey, put this table into my columnar engine also. And I am not talking about index. This is columnar engine itself, keeping the data in memory on a columnar store itself, right? I can either ask AlloyDB to put that table into columnar engine, or I can ask AlloyDB to, hey, monitor my workload and see which specific workloads or which specific tables need to be put into the columnar engine. Both of them are possible for you. Now, once that is done, now depending upon the query that you are kind of throwing, the optimizer will decide whether it needs to use your regular indexes or it needs to use the columnar engine. If it decides columnar engine is better because this is kind of an aggregate query for me, it will use your columnar engine, and again the hot refresh data and everything will come into the picture. Depending upon what workload is coming in, it will kind of use optimizer's capabilities to understand where it should actually throw or get the data from. That's how it works. The same feature is available in Omni as well, right?
So in the interest of time, I think we'll have to wind up now.
Sure.
But-
we have to,
But I just wanted to make sure, guys, get some time to
Okay.
come by and join here for Sriram's session.
but we are available.
And yeah, all of us are available at the booth. Don't hesitate to come over there, talk about your use cases, and we can go in depth into details. If you want more architectures discussions, we can do that also. Yeah.
So we can go as deep as required.
Lunch is served in the ground floor. There is restaurant. There is down there, we will go to fourth floor also.
And thank you so much for your interest and staying beyond the time. Thank you so much.